Daniel O'Connor of Hydroarmor Systems. Today's job is a horizontal crack. Now, this wall was about to fail. The primary issue on this job is the bottom of the wall. That has to be pushed over. And once upon a time, someone installed a half-assed pressure relief system. Had this system been installed properly, this would never happen. This is where the foundation was, and the bottom of the wall has shifted 3 inches inward. On this job, this is called the pressure relief system, which means it is supposed to relieve lateral pressure. When you go with the lowest bidder, I'll show you what happens. This is a horizontal track. The reason it's here is because of lateral pressure that should have been relieved by the system. Now, can I exactly say that the system was installed before this happened? Absolutely. This is how much the wall has moved. You can see that the drain board is against the lower block. Bottom of the wall has shifted in. Lateral pressure. So this system was done previous to this happening. And this is supposed to be concrete. When there's corners cut, it ends with the concrete. I would ordinarily use a jackhammer. So there you go, okay? For a pressure relief system to be done properly, the trench has to be 10 inches beyond the footer, and it has to be dug out to the bottom of the footer. This is an 8-inch block wall, which means the footer should be here, which means it should be 10 inches beyond that. This drainage board is a little high. In every one of my videos, when I redo a system, the pipe is too high. The reason it's too high is because whatever crew did the job didn't want to dig the trench to the bottom of the footer, and if they didn't go to the bottom, then I'm quite sure they didn't go 10 inches wide. This is a wall, by the way. Here's the pipe. There's your footer, there's your pipe. And I haven't even dug this out yet. Now this, right here, this is dirt. Which means to say that all they did was break out the concrete for show, and they dug a little narrow trench just to put the pipe in, which is why the system will never work. This is dirt, not stone. They just dug a little trench and put this pipe in here. And the pipe is 3-inch ADS. Salesmen will usually show you 4-inch ADS. Looks like the same, but it's not. It's cheaper. When you get your estimates for a pressure relief system, and you decide maybe you want to save $2,000 or $3,000, this is a $27,000 repair job now that could have been prevented when the system was originally done. Now, many people will say, okay, we got to replace this wall. Take it out and put it back. Well, that's going to be about $35,000 or $40,000 to take this entire wall out and replace it. I don't need to do that. I can put this wall back in place, save the wall. There are things called wall pins and carbon fiber strips and I-beams. And you can do carbon fiber strips and leave this bow here. You can do wall pins and leave this bow here. You can do I-beams and leave this bow here. 10 years from now, 15 years from now, 20 years from now, somebody might want to sell the house. Anybody walks into this house and sees the bow, that it's been repaired, sees I-beams, well, they're going to tell you they want $20,000 off whether or not you've gotten the thing fixed 10 years ago, 15 years ago, 100 years ago. If you're going to finish the basement, you can structurally repair it without having to put the wall back in place, and it's structurally sound. It just won't raise any flags. In this case, no plans on finishing the basement, and this customer needs the wall to be put back so that if and when this house is ever sold, it doesn't have a problem and it doesn't appear to have a problem. So sometimes you have to spend a little extra money when you want to repair one of these walls. So I'm going to put this wall back in place, and I'm going to take you through the entire process. There are two absolute ways of getting this wall back to straight and perfectly sound. Number one, the way that 99 9/10 of all contractors will tell you is you have to raise the house and replace the wall. For something like this, on this job, would be somewhere between 34 $30,000 and $40,000 to jack the house up and replace this wall. What I like to do is I can put this wall back into place, make it structurally sound and perfectly straight without jacking the house and replacing the wall. Now the cost of what I do would be 25–30% less expensive than replacing the whole wall. Before we do anything, we have to brace the wall and make sure that it doesn't come in. On the outside, I will dig a relief area. Okay, so this is what we'll do. We'll excavate the outside of the home. We'll push the wall back. We'll install wall pins to keep it in place. And then on the outside, of course, we're going to do a real tight waterproofing job. We'll put a very thick tar, and then we put one solid sheet of 20 mil reinforced rubber all the way to the bottom of the footers, and water can never ever penetrate this wall. Anytime you do anything on the exterior where the wall is going to fail, you have to brace up the inside so that if the machine operator should happen to hit the wall while you're excavating, well, bracing on the inside will prevent it from falling in. Any tapping of this wall while you're excavating, it would have caused it to fall in, and then at that point you would probably have to jack up the house and replace the wall. And once upon a time, someone installed a half-assed pressure relief system. Had this system been installed properly, this would never happen. This is where the foundation was, and the bottom of the wall has shifted 3 inches inward. Before we dug out the foundation, this crack was much larger. Once we relieve the pressure on the outside, the wall has actually moved back all on its own. Remove that earth, and then the weight of the house will cause the wall to just come back in place, because it's the weight that pushes it down and wants it to straighten out, which is what has already occurred. The primary issue on this job is the bottom of the wall. That has to be pushed over. So, that's that. We'll finish it, and I'll show you the end result. We've reached a final process in this job. If you look at how we finish the walls, now that is a 20 mil rubber / plastic reinforced. You cannot penetrate it. It comes in 12 foot by 100 foot lengths. You can completely encapsulate the outside of the foundation. What we do is we'll power wash the outside walls, we'll put tar on there, and then glue the plastic to that. No water can ever penetrate it. That rubberized plastic will be there forever. Now, as you can see, we've got Hydro Dog supervising. All right, so I'm going to backfill this now, clean it all up. As you can see, it's a great big fat hole. That's about it. I'm going to backfill and we'll get this job finished up. Okay, so this job is a wrap. We threw in a nice patio for him, and this foundation wall is now more structurally sound than the day it was built, and it's also more structurally sound than had we replaced the wall. Okay, let's go inside. This is the wall that had the massive bow in it. All right, this is where the crack was. This is the remnants of the crack. This is how tight we got the wall back. Now, I remember you can come along here. Well, I can't even see the crack. I can't even see the crack. If you can't see the crack, so I'm going to have to put my glasses on. Let's see. Oh yeah, see this little hairline crack here? Believe it or not, right here is the crack. Look at this. This is fucking beautiful. You can't even see where the crack was. How the bottom of the wall was kicked out. It's nice and flush. All right. That massive crack is gone. And I'm the only person in this industry or any other that does this. If you can find somebody else that does this, well, they've probably seen my videos. That's right. We bet. Cool. Let's get the fuck out of here.